Hi, we're in section 8.1 and we're going to solve this 3x3 application together. A movie theater charges $11 for adults, $6.50 for children, and $9 for senior citizens. One day, the theater sold 405 tickets and collected $3,315 in receipts. Twice as many children's tickets were sold as adult tickets. How many adults, children, and senior citizens went to the theater that day? So the first thing we have to do is label our unknowns, and I'm going to write it out so that I can reference it later. I think I'll use A for the number of adult tickets. And I will use C for the number of children's tickets. And then I will use S for the number of senior tickets. You can use any letters you want. I kind of like them to match up with the words, but it doesn't really matter. Okay, now since we have three unknowns, we need a minimum of 3 equations to be able to solve for them. So we're going to look for some relationships in the problem. The simplest relationship is here. It says that they sold 405 tickets. That's the total. So if I add up A plus C plus S, I should get 405. Secondly, we have this money relationship. We know the total amount that was brought in. We also know the price per each type. So adult tickets brought in 11 times A dollars. For children's it was $6.50. So each, so times C, plus, for seniors 9, so 9 times S. And that should add up to 3,315. The last relationship is shown here. Twice as many children's tickets were sold as adult tickets. So they sold more children's tickets, a lot more. So the number of children's tickets is twice the number of adult tickets. So C equals 2A. So now looking at this system, we need to figure out how to solve it. You could use substitution or elimination. Since C is conveniently isolated here, I think that we should do substitution. Because we can go back to these other two equations and replace C with 2A, and that should bring us down to a 2x2 system. So let's go ahead and do that. So I'm going to replace C here and here with 2A. So let's do that over here. So I have A plus 2A plus S equals 405. So that is 3A plus S equals 405. I'll do the same thing for the second equation. 11A plus 6.5 times 2A, replacing C with 2A, plus 9S equals 3,315. So 11A plus 13A plus 9S equals 3,315. I can combine like terms. 24A plus 9S equals 3,315. Looking at these numbers, 24, 9, and 3315, they all are divisible by 3, so I think I will divide both sides by 3 just to make my numbers smaller. I don't have to do that, but I like to work with smaller numbers. So I have 8A plus 3S equals 1105. Okay, so what I've done here by replacing C with 2A is I've broken this down into a 2x2 system. So if I look at these equations that I've boxed, let's name them A and B. I can now use substitution or elimination to solve this system. I think I will do substitution. Not substitution, I think I'll do elimination. I'll eliminate the S. So I think I'll do equation B plus -3 times equation A. That way I can eliminate S and then solve for A. So I write that down here. So here's equation B, 8A plus 3S equals 1105. And then I'm going to multiply equation A by -3, the entire thing. So it'll be -9A minus 3S equals negative 1215. So I'm adding these together, and when I add them together, you'll see that the S terms get eliminated. You add them, you get 0. So negative A equals negative 110. Divide both sides by negative 1, so A is 110. Okay, so there's one of our solutions. Going back to this equation over here, C equals 2A. I can solve for C pretty quickly. So C equals 2 times A, so 2 times 110, so C is 220. Okay, and the last one I need to solve for is S. I can use the top equation, the first one we got. We know the total, so A plus C plus S is 405. So 110 plus 220 plus S is 405. So 330 plus S is 405. Okay, subtract 330, so S is 75. Okay, so now we have all three unknowns solved for. Let's go ahead and write out our answer. Okay, so they sold 110 adult tickets, 220 children's tickets, and 75 senior tickets.